Hi, welcome back. So in this session, we are going to continue to discuss the DevOps and continuous integration terminology and concepts. Okay, let's go inside. In last session, we have discussed about what is DevOps, why we need DevOps, and what is the purpose of DevOps, and the continuous integration advantages. So continuous integration, CI/CD, continuous integration and continuous delivery or continuous deployment. So we need to always remember the 7-step program. Okay, what is those 7-step? Basically, we need to always keep remember this 7-step and we will move on. First step is commit early, commit often. So the idea here is whenever there is a bug, so there is a notification using the collaboration tool, it will be notified to the developer. So developer will review the code again and commit, means GitHub means he will push the updated code. Git push. I'm just giving an example. So git push. So which means he modified something and he is committing it. Okay, so the moment he pushed, automatically CI tool will detect, oh, there is a change. So again, start compile, okay, and then once compiled, start build, okay, and once build, so I will get, after this build, we will get ER file if it is a business logic with, or WAR file. It depends on the application and depends on the development language, right? So then it will store it in Artifactory or Nexus kind of a repository, Artifactory or Nexus. So there are a lot of tools. We will discuss it one by one. Artifactory. Okay. So step one, commit early, commit often. So whenever there is a bug or whenever there is a change, immediately do the commit. So the moment you committed as a developer, again the compile and build has to start immediately with the help of CI tool. And never commit broken code. Before commit, please validate. I am a developer. I have to make sure whatever I commit to the source code management repository. Of course, anything you can use it. Each project, they are using different perspective. There are a lot of SEM tools. So never commit. If I am a developer, I am committing something. That means I need to always have a cross check from my side. Whatever I'm committing, the code is error-free code. There should not be any issue. But of course, there will be validation. But you have to have some self-responsibility as a developer. Okay, this is the second point, thumb rule. And fix build failures immediately. This is what I told. So as a developer, I have got some alert ticket. There is a build failure or there is a bug. So what I need to do is I need to take that specific code branch from SCM repository, okay, and say git pull or a specific branch, and then start work on it, fix it and commit it. Okay, which means I am doing my part always. Okay, I don't have any dependency because all I need to do is what is the bug, which release, go for that specific branch, download it and replicate your development part, and you start develop towards the fixing. So once you satisfied, you push it to the source code management repository. The moment source code management repository see the changes detection using the CI tool, Jenkins, Circle CI, so automatically it start repeat the process and the application base will be created. So once the CI completed, then CD will start. Normally, if it is a bigger production environment, they will first deploy it into the staging UAT. So there are a lot of environments which they need to keep test with multiple audience and fail fast. The moment I check the code, the moment the committed, the moment the compilation started, the moment build started, the moment the application artifactory code has been saved along with the code saved, then it has to deploy in some testing environment to test further, right? So for that, if the testing is failed, again, the whole process has to start till it gets zero error. Okay, zero error user experience. Then only actual CD will start, production deployment will start. So the more you fail fast in this repeated process, the more you can deliver the code stable. I mean, the product is more stable. You can deliver the product more stable. So the step 4 also, thumb rule, fail fast. Okay, and act on metrics. Okay, so in this case, you need to keep collect what is happening, artifacts. In another area is artifacts. So you have to keep collect what all happened, what happened. Without that data, you cannot decide what is the problem and how to fix it. Further, you cannot take the decision on how to fix it. First, I need to know what is happening, right? So you need to keep collect the artifacts, means the logs and errors and almost all each and every version branches, whatever, including the branch, including the code where stored, everything has to be collected. Because when the developer receives the actual ticket, right, he needs some kind of a background information without which he cannot recommend any solution, right? So that is why you cannot manage what you don't measure. So you need to keep measure. Then only as part of service improvements, with the help of collected metrics, you can give a fine tuning on your deliverable towards the service improvement expectation. Correct? So let us go further. Build in every target environment. Before going to the actual production deployments, you need to build. There will be a lot of environments before pre-prod, before actual prod. So you deploy it, and with the different audience, you test it, or with the different test use cases, you test it. Okay, so this step 6 also more critical, because with the same product from different audience or different environments testing, then definitely you will come up with a lot of surprises which has to be fixed if you are expecting to deliver a stable product, a universal product, right? So let's go another one. Create artifacts from every build. What is meant by artifacts? Say for example, you checked in code version 1, right? The moment you checked in your source code management, GitHub or Bitbucket or any source code BSTS, the moment it has to start the compilation, compile. Okay, the moment compilation start, automatically build will start, right? So the build once started, okay, it will create the application package, right? I'm talking about Java, but you can apply this logic, whatever the programming language, you can suggest it. So warfare, right? So normally the artifactory nexus more usable by the most of the clients. So you need to store this plus the exact code plus during the compilation there is a XML file. Okay, then there is a Java file. So everything has to be stored as a package with this specific version 1 name, right? So why I need to store every version source code plus files plus created application. So everything I have to store. Why? Because tomorrow if there is any bug, right, developer need all this information to quickly recreate the specific dev environment, because I need to create a environment for that version. Then only I can fix the specific error on the specific version to provide back to the customer solution, and also merge the specific fix to the upcoming deployments, right? So artifacts is really important for each and every commit. Every build means what? I am doing something, I am checking out. So the moment I committed automatically into the GitHub or Bitbucket, automatically the build will start. Build means what? I'm creating an application on the specific version. So you need to keep store all these files under version 1, right? So these are all very much critical factor to go for any DevOps projects to lead with. And again, we will reiterate, commit early, commit often. Never commit broken code. This is the major responsibility of those who are working in this specific environment, especially on the developer side, right? Fix build failures immediately. The moment he check the code, start and test it. And the more you fail, the more we can ensure there is an issue, fix it. Okay, and keep on collect the matrix where why we are failing the build, why we are not able to create the successful deployment. So all these logs metrics will help you to address the performance issues, address the production application related issues, everything. We need some data, right? Build on every target environment. Then only the more you test, the more you deliver a stable product. Okay, and create artifacts. So whatever you do, you keep store the raw code plus the created application packaging. Okay, let's go further. Continuous integration can help you with a build better. Okay, and you can create a quality software very fast. Why? The process once defined in the pipeline almost going to be the same procedure every time. The moment the developer check in the code, the procedures are going to be automated and very fast. And we are going to start using CI tool. Before going to the Jenkins, okay, the reason why we are going for a Jenkins is Jenkins is an open source, right? So before going to the Jenkins, right, you need to understand what all similar production related enterprise grade tools are available. In market, TeamCity is widely used and CloudBees is widely used, and Travis CI, it started famous, and there is a Circle CI. Circle CI also one of the very good CI tool. Okay, and Bamboo also most of the clients are using. And if you are thinking for AWS cloud native based tool, then AWS having code pipeline, and there is a Git lab also having the similar functionality. But I would suggest to go with Jenkins, because Jenkins is widely used for open source tool, will have more plugins. So those who are just starting the DevOps, I would strongly recommend to go with Jenkins and TeamCity. These two are almost same functionality, but TeamCity is having more advantages, right? To start with Jenkins, understand all functionality, all integration, all triggering, all configuration, everything. First learn with Jenkins, then start do the same in TeamCity and also Circle CI. If you are familiar in these three, wherever you go, any project, you apply the same logic, just change the tool name. That's all. Tool name, the procedures, the process, the concept, everything is same. Only the product related specific features will be different, right? So but the logic wise everything is same, right? And Jenkins, what is continuous integration, right? Why we need it? And what are the different phases of continuous integration? Okay, so we will have a simple example. He is the developer. He's created some Java code and pushed it to the GitHub, right? The moment he pushed the Jenkins, I configured this repository. Okay, so automatically it will detect the changes. It will start build, and build means compile and build, and then it is getting failed. Again, the developer will receive the notification, failed build notification. Automatically, again, he will fix it, commit it. So the Jenkins, if detected the new code, okay, change the code version, automatically this process will start again. So like this only the continuous integration will start happen, right? This will help to make sure your product is more stable, because you are keep on doing immediately, right? Why we need continuous integration? This is the biggest question for everyone, right? So as I said, just a simple diagram, detect problems or bug as early as possible, because first time you are defining the source code repository, GitHub or Bitbucket or GitLab or VSTS, and integrating with one CI tool, right? So CI tool, the moment you integrate it, automatically it will start see every second. You need to schedule, right? According to that, say if you schedule every 4 hours, so every 4 hours it will come and see, is there any changes? If there is a change, start it. What to start? You already defined what to do. Compilation, build. After build, you also need to configure where to store, because Artifactory software, just now we discussed, right? So this is a major advantage if you go with continuous integration kind of a design, right? Since the entire code is base is integrated, build and test constantly. All you need to do is you need to make sure you are changing some code and pushing it. That's all. The rest of this part is going to be already defined, automated, right? So this is what most of the people started doing in DevOps, and different stages. Okay, so here also the same story, fewer releases. Okay, this is a central repository, source code management, fewer commits. So if this developer is doing some commits, it's fine. Even fewer commits, it start do the same compile, build, and test will happen immediately. If it is failed, again the build notification, again he'll fix it again. So until the test is successful, this process will be repeated. This also few releases, version 1, version 2, version 3. For this release, any code changes also, the same process will start happen automatically. Okay, and stage 2 also, he commit the code, okay, and you define compile, build, and till the successful build. Once the successful build, you can define CD. Okay, when I need to deploy, because that should controlled by you, means the CI tool, because you cannot allow just like that there is a change, immediately you can build and deploy. The deployment has to happen on a specific period, especially on the pre-prod and production. So you need to have, say, every early morning, night, or after business hours or weekend deployments. So you need to decide this. You can, there is an option, you can mention it. And the further one is stage 3. So build trigger, the same process, we have split it out small stages. So in this stage, the build is triggered whenever there is a new code. Okay, because there is a previous fail, he fixed it, and there is a trigger. So this has to be happen automatically. So if it is automatically, then in CI tool, you need to mention the periodic interval. So if you mention this, automatically what the CI tool will do is, CI tool will, during this interval, it will keep on go and check, hey, do you have any changed code? Do you have changed? These questions will be start asked from the CI tool. If he got any reply during the analysis, automatically this process will start. And the stage 4, I started trigger, and the trigger will start the build and commit. Automatically what will happen is, if there is a failure, again it will go to developer. So he will download the specific branch merge, and then he'll start fix the code. Again he will commit it. So once all this process completed, then now I have a created application after all testing. Then what will happen is automated deployments. This is the CD. Actually, there is a two CDs. One is continuous delivery, continuous deployment. Continuous delivery will make sure you deploy first before production environments and test it. And if everything is okay, then go for actual production deployment. You need to have a proper change schedule agreed, and then you deploy in the production environment. So this is how you need to understand the CA and CD tools, which we will see it in very simple way of Jenkins environment hands-on. And this is one of the sample diagram. So they are the developers. So they are changing the code and committing it. So the moment they committed in GitHub, automatically the Jenkins already you configured, this is the repository. So it will go on the check based on the interval you defined here, every 4 hours or every 6 hours or every day morning. So you need to define. So once you defined, you forget it. Jenkins will take care, because Jenkins is a CA tool. So it will check there is a changes, pick it up and compile it, build it, right? And once built, it will store in the Nexus or Artifactory. There are a lot of products. So store it. Okay, keep it. Then it will also check the deployment. So it will test the code, and once it's passed, then it will start go for it, because this testing will have multiple mechanisms. Here there is so after test, again it will go for CD process. So this is only CA process. So after CA process, everything is okay, then you go for the further environments. Okay, so once these are all passed, then you need to start with production based deployment, CD. Okay, this is how the logic works. And further, this is also one of the simple diagram. Check-in, CA tool will trigger, failed, and collect the artifacts, go back. Again, he will fix the bug, check-in, trigger. So there is a passed. So go further testing. Testing is failed. Again, feedback sent to developer and test it. And once fixed, check-in, trigger, completed, fine. Then further testing also completed. Then end user related testing also completed. Then release also completed, because you are releasing in different environments. After this, you plan for your production deployments. After this, you actually plan for your production based deployments. So this is how you need to plan if you are going to join any DevOps projects. Okay, and further we'll go continuous integration, continuous delivery, continuous deployment. Okay, and as I said, continuous integration means merging the development work with main branch constantly. Like whenever there is a request received, you fix it, commit it, fix it, commit it. And continuous delivery, whenever you fix the code, and whenever you compiled, whenever you build, and whenever you tested, and then you put the product in QA and further environment, not actual production environment. So this is the part is actually production environment. Okay, and then you further go and what is Jenkins? Jenkins, as I explained, it's a continuous integration tool, right? So whenever there is a change detected, automatically it start the compile, build, and create the application packaging process. And if there is any issue, immediately also start notify with the help of already integration and collaboration tool. which integrated already with this CI tools. Okay, then why Jenkins popular? As I said, Jenkins is it's a huge open source with a large community. So those who are looking for CI/CD as a starting point learning, strongly recommend start with Jenkins, but don't stick with Jenkins alone. Jenkins plus one enterprise tool also, like TeamCity, some Circle CI. So one or two tools you integrate whatever you are exploring in Jenkins, the all functionality you also do it in Circle CI, TeamCity kind of a tools also. The procedure wise same. Some product related settings experience will be changed. Okay, and when you test in the production, you need to define one master or multi-master with multi-slave to make sure you are not in the single point of failure. Always this is recommended in any of the production environment. So stay tuned. We will come up with more hands-on. Thanks for everyone.